Hi everyone. Hopefully you can hear me okay. All right, I've got quite a few slides to get through. We'll see how we go for time. I haven't actually rehearsed it, so we'll just jump straight in, and we've got some code at the end, and we'll show if we've got time. So what are we talking about? We'll just quickly touch on microservices, just a quick refresher. We'll keep that nice and short. What they are, how we got there. We'll talk about service meshes in general, what is a surface mesh, and then more specifically we'll talk about Istio. All right, so a traditional application is pretty simple. It works easily, you can deploy it. Sorry, I'm just bringing up notes. It's easy to debug, it's easy to deploy, it's easy to work with small teams, but as everyone knows, businesses do evolve. Okay, the clicker's not working. Sorry. Okay. Yeah, businesses evolve. Nothing ever remains that simple. So over time, your application is going to get bigger. It's going to bring in additional requirements for the business, and you'll still stick with that one repo for a while. That'll obviously bring some challenges in terms of having a single language. You kind of, to an extent, you're restricted in terms of what you can actually achieve there. The business continues to grow, becomes a lot more complex, and you really start to hit some issues around being able to deploy. You get into situations where you need to roll out a deployment and you've got an ETL pipeline running, and you have to basically kill everything and redeploy from scratch. So there's a point where the size of the infrastructure becomes too big, and at that point you need to look for something a little bit bigger. And that's where microservices come in. So it allows for a separation of concerns. We can actually pull those out into separate repositories. We can start to utilize independent languages, so things that are fit for purpose. Not every language is going to be suited for every problem set. So using the right language for the right situation. And it allows us to deploy each of those services independently. So if we've got our ETL running, we don't necessarily have to stop things when we just want to make a quick web fix at the front end. So just a quick poll, who's running a microservices architecture in production at the moment? There's a couple of hands. Cool. And has anyone actually found it to make their life easier? I think a lot of people kind of head towards the promised land. They go and move towards a microservices architecture, and then they find that they've just basically they've swapped some problems. So we start to find that we've got inconsistencies in terms of the language. We've got one language that has maybe an implementation for whether it be a security protocol or something else, and that doesn't necessarily align with another language. So we quickly start to find, although we got a benefit from using different languages that fit for purpose, now getting consistency across the landscape becomes a bit of a problem. Processes become a lot more fragile. So when we are deploying things, there will be dependencies between processes. We need to test all of the services all the time, so we need to have a lot more rigid infrastructure in place around that. There's also a duplication of effort. We start to introduce things that we've solved for one language or for one problem area, we then restart re-implementing. So we're moving away from actually solving the business problems, and we're now just starting to churn on actually solving the infrastructure problems to run the thing. There's also a lack of visibility across the operations. So we've got operations that hit the microservices, it flows through each of the services, but how do you actually get the visibility across all that? That becomes quite a challenge as the number of services involved in an operation do grow. And things become a lot harder to debug. So as you're debugging, the problem is not always where you start. Sometimes you have to go down 2 or 3 levels in order to find the actual problem. And this is where team communication really becomes crucial. If you've got one team working on something, when everything's in one repo, it's nice and easy. If someone touches it, it's going to break the build for everyone, and it's pretty obvious what's happened. When there's a breakdown in communication, team A is not talking with team B, you can very quickly get into situations where we actually forgot to tell that other team that our service now no longer supports or deprecated a particular version or a particular API endpoint. So these types of things sometimes don't bubble up until things are actually in production or near production. Yeah, obviously dependencies and in deployment, you may need to actually roll out 2 or 3 dependencies in a staggered order in order to achieve a safe deployment. So we swapped all those benefits for more problems. So what are we missing? I mean, a lot of people will go looking for microservices as a solution, and they'll get a little bit frustrated. And I think that's where you need to actually look for tools such as Kubernetes, Docker, Istio, to start to help to solve some of those problems, to abstract some of those problems out of the service, and to kind of manage that at the infrastructure level. So hands up if you use Docker or you're pretty familiar with how Docker works, just so I've got a guide of how many people. Okay, so yeah, Docker's pretty well known these days. What about Kubernetes in terms of people using in production at the moment? Okay, there's a couple. That's good. That's good. Kubernetes is a thing of beauty once you get it going, but it's a pain in the butt to actually get there. It is an enormous amount of learning up front and a lot of YAML along the way. So, cool. So what does a microservice look like in Kubernetes? I've been practicing my drawings, so excuse some of the drawings. Most of the presentation is this way. I was a little bit late in the day, so I thought I'd mix it up with a little bit of colour. So at the end of the day, a microservice is just a container, one or more containers bundled into a pod, which is the kind of smallest unit of work within the Kubernetes infrastructure. And the reason we're talking about Kubernetes is because Istio is typically used on top of Kubernetes. We'll then expose that through a service inside of Kubernetes and then potentially out to a load balancer to the internet. And that sits on a set of nodes. So that's kind of the basics in terms of our microservice. But we're missing a few bits. We're missing traffic shaping in terms of canaries. Rob had a great talk earlier in the day where he talked about canaries and some of the cool things you can do around shifting traffic. Service level authorization and authentication. How do we actually make sure that 2 services inside of our Kubernetes cluster can actually talk and should talk to one another, and we don't have a service compromised that's sniffing traffic around the namespace. Service discovery, when things pop up into the landscape, it's ever evolving in terms of an architecture. You draw an architecture diagram one day and then 3 months later it's out of date. How do we discover services? The tracing I touched on earlier, again, another problem. So we've kind of moved down the path in terms of bringing Kubernetes. We've allowed ourselves to at least manage the microservices and make it easy to deploy and load balance them, but we've still got a lot of problems. And then cascading failures is another big issue in terms of the knock-on effects of you've got your microservices and then you start to have issues and that pushes down the line and can potentially bring down a whole bunch of services. So this is where Istio comes in. It means sail in Greek, if you didn't know. It's an open framework for connecting, securing, controlling and observing services. So it's really there to act as the glue around the services that we're deploying. And Istio uses a pattern called the sidecar proxy pattern. Essentially, if you're not aware, that is a sidecar on the side of the motorbike. It's essentially actually I'll explain it here. So there's 3 types of patterns I'm going to show here. The first is, and the second are not a sidecar proxy, the third is. So this is more of your traditional, you've got a service, you've got a client library, and then you're talking to another secondary service. We've got something where we've got service A and we're load balancing off to service B, so we're starting to put something in the middle and we can potentially control some of the traffic that's going between service A, service B. And then we've got sidecar proxy, Just like the motorbike there, the sidecar proxy sits inside the pod, so inside that smallest unit of work that's deployed onto Kubernetes. And those proxies sit and wrap the communication around the actual service. So when we've got service A talking to service B, it's actually the proxies that are talking to each other. It's not that service A is calling to service B directly. They're going through the proxies. All right, so that's sidecar proxies. For Istio, they use a thing called Envoy. So it's a layer 4, layer 7 proxy, which is basically the protocol and application layers of the OCI model. It's battle tested by Lyft, so this is the competitor to Uber. They have some crazy stats around the numbers. They're pushing something upwards of 2 million requests per second through Istio, so it's been tested at some pretty serious scale. It supports both HTTP2 and gRPC, which is Google's protocol. So it's up to date with the latest stuff. This one's a really important one. It's an API-driven config, so the proxy doesn't, if you've used Nginx or something like that, you'll have to reload a configuration when you're actually refreshing anything that's going into the proxy. Envoy is a little bit different in that it's an API. You push your configuration change to the proxy, it saves it, the next request that hits will get that. There's no downtime, there's no delays in terms of the way the proxy works. So it's really good for high throughput. And it's got all the goodness you'd expect in a next generation proxy. It's got health checks, circuit breakers, and many more. And the routing and traffic management, so it can help shift information around between the actual microservices. So this is what a microservice looks like within Istio. We've got a couple of servers here. We've got the front end, we've got a billing system, an image service and an authentication service. And as I just touched on in the earlier slide, the proxies are actually the thing that are doing the communication. In terms of Envoy, it adds approximately a 1 millisecond overhead in terms of the latency. Obviously, we're going through a secondary piece of software, but the overall latency is pretty minimal when you consider some of the benefits that it provides. All right, so this is a little bit more about what Istio can actually do. So routing, obviously, it can handle all the stuff we've talked about, the canaries, the traffic splitting, the traffic monitoring. Rob went quite deep into that earlier on. I can help with staggered rollout, so we're actually ratcheting up the percentage in terms of as the traffic's going through. Timeouts, retry logic, circuit breakers, fault injection. Again, Rob touched on a lot of the goodness there. Security. This is one of the key benefits of Istio. So it's got mutual TLS authentication, so that's end-to-end encryption across all the service communication between the proxies. Policy management, so you can actually control everything through YAML, and a whole heap of features around quota management and things like that. And it bakes in dependency tracking or service tracking into the actual framework, so the mesh can see as things are actually happening and react to that. Okay, so there's 3 key parts to Istio. There's Pilot, there's Citadel, and there's Mixer. So you can think of Pilot as the thing that builds an in-memory model, an abstract model of the service mesh. It's pulling information in from configuration, from service discovery, from other rules. It's building a model of what the mesh is looking like at the current point in time, and then it's pushing that out to each of the proxies. So it will actually push that out to all the proxies so everyone kind of knows where things are at. We've got Mixer that's actually storing the policy information and the telemetry. So Mixer is actually used, and I'll touch on this in a bit, in terms of actually each request. And then Citadel is the security piece. So it's actually issuing the certificates out to each of the proxies, which then enables the MTLS authentication with certificates. Cool. All right, so Mixer, it's built for high availability. It is a pretty reliable piece of kit. It's built with an adapter plug-in. So, and you'll see this through all of the Istio framework. It's built to be plugged into multiple different clouds. It's not kind of boxed. They've tried to keep it as open as possible. It's a part of the Cloud Native foundation, so there's a lot of different contributors putting work into this project. It controls the policy and telemetry information, and it's an abstract layer that, as I said, that wraps around each of the operators or cloud service providers. So Mixer is responsible for kind of the precondition. So when a request comes in, the proxy will talk to Mixer. It'll do some precondition checks based on the configuration to determine what should happen. Should that actual request be allowed to occur, or should it be killed? It'll then let the request happen. It'll then call back with the telemetry information. So it's feeding that information back so that we can continue to track and observe what's actually happening with the mesh itself. All of, as you can imagine, that kind of rate of querying for every single request, that's going to put a bit of a strain on the mesh itself. So it caches everything at the proxy level. It'll have a local cache there, and it'll have a secondary cache also in the data plane as well, inside Mixer. And in terms of the outgoing, so that the telemetry going back into Mixer, it'll buffer that. It won't actually, for every single request, push that out. So you'd expect to see some buffering occurring there. In terms of how Mixer kind of determines what should happen in terms of the pre and post conditions, it uses attributes. It's basically an attribute engine. Like everything, as you can see from the examples, everything is stored in quite simple text, and you can build some really powerful rules around that. You can, as you can see there, it wouldn't take much to build a rule where you're looking at the source IP or the request size, the request path. So these are kind of the foundations that enable some pretty powerful features to come out of Istio. All right, so Pilot consumes the information, builds the abstract model, and then pushes that out to the actual proxies themselves. It originally was a pull-based model where it was all of the proxies were pulling, but they've switched that around, so it's now push-based model, which has obviously improved the performance quite dramatically. And just in terms of the actual rate, I think as of the latest version, it's sitting at around 500 proxies per second. So it's actually, depending on the size of your mesh, it can take a couple of seconds for that configuration to roll out. But that's still pretty quick when you think about it. The last piece is Citadel, which is the security piece. So that's, as I said, controlling the certificates in terms of making sure everything's secure end-to-end, in terms of enabling encryption by default, and defining the policies in terms of what can talk to what. Cool. All right. So I'm just going to take you through a couple of code examples, and we'll just see how this is all YAML-based. So the first one is a mesh-based policy. So we've got the ability to define mesh-level policies, namespace-level policies, which is a construct within Kubernetes, and also down to the service level as well. So here we're just setting MTLS as kind of like a default across the mesh. We want things to be secure by default. The service role is basically allowing us to define roles around our services. So we've got services in the mesh. We can actually start to define roles based on a bunch of things. We may have version 1 and version 2, and we actually want to restrict or change how security permissions work. We can actually configure that at quite a low level. And again, we're using those attributes. You can see there we've got request.headers version. We're basically building or using those basic building blocks to start to define some pretty cool rules. And the service role binding is kind of the final piece that allows us to connect that all together. Cool. All right, so the networking API is what really allows a lot of the fancy traffic shifting and shaping technology. And there's four key parts. There's the gateway, which is the thing that basically configures or wires up how we talk to a load balancer. That's our kind of incoming egress configuration. We've got the virtual service. That's basically the definition of a service that's addressable within the mesh. We've got the destination rule, which is where we can start to put rules around a destination, and we can actually start to restrict based on what's happening in the mesh in terms of how often we actually connect with a certain destination, or how we shift traffic based on that. And service entry is the last one. That's basically for our external services. We can actually start to put rules or security in place for how we go outside of that. Have we got comments after that? Or is it, yeah. Cool. All right, so this is the gateway. As I said, this is the piece that is defining how the load balancer is going to be wired up. So this if you've used Kubernetes, you may have used ingress definitions. This is kind of like superseding that at the Istio level, which is will actually automatically configure it at the load balancer. So we've got a basic certificate set up there for a single host using HTTPS. The virtual service is our service we're talking about. We're starting to define some attributes like subset there, which is a version 2. So we can use those versions to start to define how we move things around. The destination rule, this one's pretty cool. This is where we can actually start to put in place some restrictions. So if we've got a Redis service, for example, we might want to restrict or cap a timeout, so we don't drain out the number of connections that are actually hitting the service. So there's a whole swath of settings you can set there, from max connections to timeouts. There's a whole bunch. You can, if you've got database connections, other things like that in there, you can start to protect some of those assets and actually restrict. Cool. So that's it for code there. So where do you go from here in terms of, obviously there's probably a lot that I've discussed there. I think the first thing is if you're going to go down this path, you've got to learn to love YAML. It's you start with Kubernetes, you learn to love YAML there, and it only gets worse from there. That you will end up being a YAML engineer. I think if you're going to go down this path, you're going to utilize something like this, you need to start slowly. You need to make sure that it is something you want to commit to. I act as a CTO for two different companies. We use it for one, we don't use it for the other. It's not necessarily a fit for every situation. So you've just got to make sure that if you are actually going to use it, that you actually do need it, because it is certainly a commitment. You need to understand what you're signing up for, and you need to invest in your team. It's not a small task to get this stuff off the ground and keep it functioning and keep it going when people leave the team. So you're going to have to invest a bit of time and effort into the actual team itself, and make sure that you've got the skills to cover your bases. The worst thing that could happen is you end up with an architecture that no one knows how to maintain or work with.